Okay, welcome to my fun talk about Javassist. Um, my name is Anton. I work for ZeroTurnaround. I work and live in Tallinn, Estonia, and I've been working on Jrebel. If you know, do you know about Jrebel? Okay, everybody knows. You know probably even more than me now. Um, So yeah, I worked on Jrebel, and I work on another product which is called Extrable right now. And those two products are both using Javassist very heavily inside. And that is why I'm talking about it today. So I will share some tips and tricks and some hacks, if you wish. And what about you? Why did you come here? I have no clue. So I can only assume that you are probably interested in Javassist, maybe. Or maybe you have read the abstract and you want to become a better programmer. Not gonna happen, sorry. Or you are interested in bytecode instrumentation and stuff. Anyone have been using Javassist before? You could go to another session because it's very introductory talk. You hardly will learn anything new if you have used it before. Maybe at the end of the talk you will have some insights into Jrebel internals, but that's it. Like most of the information is very basic for those who haven't used it before. So you have been warned, and if you are getting asleep after, then blame yourself. All right, so bytecode instrumentations is literally everywhere. If you are thinking that you haven't used it before, you're actually using frameworks like Spring. Spring, anyone? Java EE, Hibernate? Hibernate, everyone. So actually, those frameworks do a lot of bytecode instrumentations. Even if you don't know about it, you recognize this code, right? Everybody have been writing it, at least in tutorial. That's Hibernate. And if you go inside Hibernate and look up the source code, you will see, hey, there is a proxy factory that is a Javassist API. Actually, Hibernate is actually the biggest user of Javassist in all the frameworks. Most of the frameworks are migrating off Javassist. They are not using it that much. But we will see later why Javassist is fun. So most of the frameworks are actually using Javassist to generate proxies. Pretty much any framework. If you pick up the source code, analyze it, you'll see it only generates the proxies. It doesn't do anything else. And that's boring. That's not interesting. Like you will not learn any fun stuff from this. So we are not talking about proxies today. It's more interesting to talk about hacks, right? And actually, Jrebel is full of hacks. Extrable is full of hacks. And we will see what kind of tricks we are using to implement our features. So today we will have an overview of Javassist, like the very basics, a little bit insight about Java agents, because they are helpful to implement real tools. And we will have some applications as well, and a little bit of Jrebel, of course. So Javassist 101. Basically, it looks very much like Reflection API. You start from the class pool, which is a representation of a class path. You can think of it this way. You get access to the classes by accessing this class pool API. From there, you get the CT class representation, which basically represents the bytes of your classes. From there, you can iterate over the elements of the class, get access to the fields, methods, constants, and so on, and do all kind of instrumentations, like insert some code before the method, after the method, change some statements, and do all kind of hacks, what you want. So let's see a very simple example here. We have a class pool, which basically represents the system class path. You can get access to all the classes that you have in the class path. From there, you can proceed. In this example, I just want to generate a new class that is not present in the class path. So the class comzt.a is just generated in memory. It's not present somewhere on the file system. And I'm saying that I want this to extend some other class that actually exists in the class path. So the result is here. And from there, I can get access to the methods, iterate over them, instrument them, and so on. And once I have done all the manipulations, I can actually write out the bytes somewhere in the file system. And I will see, OK, I can decompile whatever I have created, the generated class, and I will see the perfectly valid bytecode. So it will be, like a normal compiled Java class. What is it good for? What do you think? Like, generate a class and write it out. Any ideas? No? All right. Well, you can specify some rules, like in XML. Translate. Java is for translating XML into stack traces, right? So you can do that. Actually, you can post-process classes as well. If you have compiled some source code into classes, and you want to apply some kind of security, encryption or license checks, or hide some constants or transform your classes afterwards, like some AOP frameworks do. You can do it with, with Javassist like this. Basically, write out the bytes and then run post-processing on those again. But you can actually do more. So, for instance, again, you have a class somewhere in the file system, and you get the access to this via the class pool, cp.get loads the class, and then you may access any method. So, for instance, you have a method foo in that class A. It's a public method with no arguments. Basically, return type is void. But then you have all kind of different, overloading, and you may have a different signature of the method. Perhaps you have parameters. And then you have to specify those type descriptors. So capital L, Java /lang/string basically represents or describes the type. And that is a nasty thing, actually, because if it gets longer, the source code is getting ugly. In real projects, you basically will see very long strings describing the types. Other stuff, okay, you have, for instance, you have obtained this foo method, and you want to print out the first element whenever this method is invoked. So you can insert some code in the beginning of the method. Let's say I'm calling this insert before. It will produce the statement system out println, and $1 basically means the reference to the local variables table. So if I have a parameter, I will just print out that parameter. And it looks so nice, like very simple to understand. Even if you are, you're unfamiliar with Java bytecode, you will still be able to do all kind of this magic. But the bad part is that it's very easy to actually produce errors in those strings, because it's not really a Java code that you insert. It's some kind of a subset of Java code, and it's very easy to crash. So in this example, I have missed this semicolon there. Boom, and it's very hard. This error message is very good, and now it tells you that you're missing something at least. But most of the Javassist messages are quite ugly. You have no clue why it crashes, especially you have a lot of strings, like if you are inserting like a lot of code at once. So need to fix that. So basically, yeah, you can do all kind of manipulations. You can insert some code before the method, some code after the method. Why is it good for? Well, you can implement some tracing. Very naive Java profiler can do that. Basically, you instrument all the code and you'll trace your program just naively and see how it executes. Or you can, implement some AOP style programming if you have your own meta information or annotations. You can post-process your classes, insert some code. Boom, you have your new logic there. Or if you have like a long method and you want to do some magic inside that method with some particular statements, there is the instrument code, and the expression editor allows you to implement all kind of logic by accessing those statements that create objects, invoke methods, access fields, and so on. So, for instance, here, if I implement this edit method with for the new expression, I can intercept all the creations of the new object. So whenever a new operator is created, I can intercept that by using this proceed method that is provided by Javassist. It's kind of a DSL. It's not present for you to invoke like directly. It's only in the strings. It only exists there. But this way, I can basically say, okay, whatever the statement does, I want the result of that, and then the original statement will be still present. I will not remove it. And yeah, so this code would just print whatever variables were created via the new operator. We use this trick for registering all the beans inside Spring Framework. So whenever your application is registering new beans, we can keep track of that. And when you update your application, we can refresh your beans so that you don't have to restart your application, for instance. Another one, that's just a fun trick. If you have system out println somewhere, just post-process and remove it. So this method call parameter basically implies that you can intercept whatever method is invoked. So whenever you have dot something on any class inside your method, you can match, verify, okay, I can see that this is a println method, I can do something with it. In this case, just remove it. Or you can also intercept field access. So you have a class, you have some fields in there, and your method is accessing those fields. And you say, okay, I don't want my method access the fields directly anymore. I can replace it with getter or a setter or whatever. So, and if it doesn't exist, the real setter, I can generate that myself, like just create new method and add to the class. But this previous example actually creates a risk of messing up with the local variables for the method. And it often happens that if you patch some library, you run it and it crashes with this error. Basically, the fix is to regenerate the local variables table for that method, or drop it for good. So the error actually means that in the new class you have, or the new method of the generated code, you have mismatching between the types table and the entries table. So this covers like the very basics of Javassist, so you can understand, okay, you have access to the classes in the memory, or you can generate new classes. You can do all kind of manipulations, but alone, it's worth nothing, basically. You either have to have a hook somewhere to intercept the class loading phase, or implement your own framework. In most cases, it's your own framework, because you implement your own programming model, you implement your own annotations, you implement your own configurations, and this is how you can, bootstrap everything. Whenever your classes are loaded, you can do all this kind of magic, and according to the configuration, you can produce new behavior. For tools like profilers or Jarable, you need a bit more. You need to hook into class loading phase. And this can be provided by using Java agents. Java agents exist since Java 5. Is there anyone who doesn't know about Java agents? Everybody knows about Java agents. Yes or no? What? All right, so there is an API, Instrumentation API, that was introduced in Java 5. It was enhanced in Java 6. Basically, it provides you the convention that you may implement this agent by just implementing the pre-main method and specify in the manifest when you package the application that that class is an agent. That's it. And it's just a convention that there is a pre-main method, it takes those arguments, and instrumentation instance actually provided by JVM. You don't implement the instrumentation interface yourself. The only thing you have to do is to implement the class file transformer itself and add it to the instrumentation instance. That's it. So when you have this implemented, you just have to have this correct manifest that specifies that this is the agent. And then you start the application with -Java agent and point to that jar. If the jar path is incorrect, it crashes. Boom. That's it. The most inconvenient part is that when you are developing this agent yourself, you have to reassemble the jar all the time. Like, you make a change, you have to rebuild it. It's very inconvenient. There are some tricks how to get around this. Basically, you have to build your own framework to, to diminish this limitation. In most cases, you have to rebuild it. Very annoying. And it's the sad part because this API haven't been evolved since Java 6. So it's been there for ages. The class file transformer just provides one method. You basically have to implement one method and include all the logic there. And in the very essence, you are interested in just these bytes that are loaded by the JVM. Basically, this byte array represents the class file itself. And from there, you can do whatever you want. Like in this case, we can use Javassist, create a representation of a class from those bytes, and do all kinds of transformations. When the transformations are done, we can return the new bytes to the JVM. Boom. Our instrumentation is done. JVM itself didn't know about what happened. And everybody's happy. So how does it look like from just try to visualize it here. Think of a class loading process as a process. It's just, something in time continuously loading the classes. And instrumentation is like something that is orthogonal to this process. And you can register new transformers that you can register more than just one transformer, chain them. And then in those transformers, you may apply all kind of libraries that you want for transformation, or maybe you want to do something else. And this is how actually Jeribo plugins are structured. So every plugin registers a set of transformers for a framework. Let's say Spring Framework, there is like 100 transformers that instrument your application, and those are using Javassist there. So let's have a demo. Just very simple demo. You can find it, by the way, at GitHub. Boom. So the agent class, very simple one. As we have seen on the slides, there is a pre-main method, there is a transformer. This callSpy method is a transformer. It implements the transform method. Let's go there. And here we have this class file buffer. We don't care about the other parameters. Start with the class pool from Javassist. Say that we want the new classes to be visible from that new package. So it's just a marker for Javassist to, like a namespace. Hey, you can look for the new classes that you need for compilation from that package. Next, you can do all kind of configuration of the logic. Let's say I don't want my own classes to be instrumented, so I wouldn't instrument my own agent classes. So if the class name matches, or the package name, then I just return the original bytes. And if I see some kind of packages that I don't want to like configure or instrument again, I can implement some more filters. Usually in real tools, they would be externalized. For instance, if you're using JProfiler or YourKit, there is like a blacklist and whitelist of packages, and you can configure them externally from the agent, right? They are not hard-coded. And in this case, it's just for the demo purposes. I have them hard-coded here, but normally you would have some kind of a configuration file that you load and decide whether you want or not to instrument the class that you're just loading right now. And then, once those filters are processed, you can actually do this transformation now. Get the class file representation from the buffer, iterate over methods, maybe add new fields, whatever you want. In my case here, I'm just adding some code in the beginning of the method and the end of the method. And let me show you how it actually works. So if I run some application with this agent that I have just pre-built for myself. So I have like a very simple application that calculates Fibonacci sequence recursively. Imagine I don't know about the logic of the application myself, and it's just the black box for me. So it just prints whatever the method is executed and shifts the indentation, right? So I get the execution path for my application right now. Basically, it just traces everything. And notice like a very interesting side effect here. The application itself, when it calculates the new number, it just prints it out, right? If I didn't know about how this application is written, just by tracing it, I can notice, okay, every new number takes longer to calculate, right? This is a nice side effect of getting the visuals from the application, how it actually works. You don't really need to measure time even to understand that, okay, your program probably doesn't behave efficiently. And then, fix it by changing the implementation to iteration, for instance. Boom. We don't have recursion anymore. So if you want to play with this code, this agent, it's at GitHub. You can add your own logic if you want and experiment. But it's just a nice skeleton for the beginning. A little bit on how Javassist is used in Jereble. So from the user point of view, it's just one jar. Jereble is just one jar, but actually internally, it consists of many jars. And every jar implements its own integration with some framework. Let's say Spring Framework, Hibernate, maybe EGBs in some containers and so on, FreeMarker, you name any framework. And the way it works, it is just, one jar. The core itself is responsible for reloading the classes. So you make a change, you recompile. The core is responsible to load the new version of the class and reconfigure your application. But then it has to notify the plugin, which is responsible for reconfiguring the framework. So let's say you are adding a new bean. The new bean has to be visible for the other beans to be injected if you want, or you added a new mapping, controller mapping. You want the framework to recognize that. So, and this is done while refreshing the configuration, the internal configuration of the framework. And all the plugins are responsible for that. So, and Javassist is used there, because the core is very sensitive to performance. It has to reload the classes quickly, has minimal impact. Javassist is not there. We use ASM in core. But in plugins, it's very easy to maintain with Javassist. I will show some real code as well afterwards. So just to explain how the process works. So for instance, you have a very fancy framework that does some kind of a configuration. When it starts, it configures itself, reads in some kind of metadata and so on. To get access to that one, again, we can use class pool, load in the class representation, and do all kind of manipulations. So what we need is to say that, okay, this internal class of a framework is now a listener of the changes, so that the core would be able to notify that listener, and that listener will reconfigure the framework, refresh everything. So we can add the new interface, because it's possible in Javassist. You say, okay, that class has to implement this interface, and of course it has to implement a new method that is provided by that interface. Boom, done. So the onEvent method is used by the core to trigger the event of the reconfiguration, and that onEvent method can call some kind of internal framework methods now, because it has all the access to everything inside the framework. Just a little demo. Yes, this one. So just to visualize a little bit, this is a very simple one. We have Jrabble, we have all the listeners registered inside Jrabble itself. Once the classes are reloaded by Jrabble, it does all kind of magic there. We can notify all the listeners, it will trigger the process of reconfiguration. So how it works in very general terms. Oh, sorry. Okay, so get access to the class pool, implement the interface, add new packages, because we want those new classes to be visible inside Javassist. Say that we want to get access to that framework class, which has just this configure method. Let me show that. Boom, it's here. So it will just print out the configuring framework string whenever we want it, whenever we call it. Sorry, how it works. Then, once we have access to that framework, framework class, and it's internal to the framework. Maybe it's even a private class. We say that we want this to be registered as a listener, and add a new method that will be called by the core itself. So the new interface, the new method. Once we have this method, we actually need to register the instance of this listener somewhere. There should be a point in time when we decide that, okay, this framework class should be somewhere inside Jrabble. It should be in the list of listeners. And that can be, in some cases, it can be done inside a constructor. So we go to over all the constructors of that class, of that framework class, and at the very last statement of the constructor, we decide, okay, once it's constructed, we can register that instance, that particular object instance, inside Jrabble, and we will just populate the list of listeners there. Here it is, right? So, and $0 means this. I can actually write it like this in some cases. Once we've done that, we have registered all the listeners, we can now start with the framework. So imagine we are now starting the application. The new instance of the framework is created, so we can see that it's running, it's calling the framework constructor, so the framework was configured. Now some time passes, we decide, okay, we change some classes, Jrabble core reloads the classes. Oops. So reload classes. By any logic, let's say I have some kind of a trigger that monitors the file system. I can see that the physical class file timestamp has changed. Now it's time to reload the class. The core has reloaded the class. It will notify the listeners afterwards. So if I call it again, I will see, okay, calling the framework constructor. This is the part that was here, right? So I injected it there. Or like configuring the framework is this method here. So that's the very basic workflow of how Cherable, interacts with the plugins, and when it decides to reload the configuration. Have any questions? Just raise the hand. No questions? Okay, you probably are using all Cherable, so you know how it works. Yep. So the question is, if this insert after, how would it look like in real code in Java? Ah, okay. So like, if I have a constructor of let's say a framework, how was it? Framework. If I have a constructor in here, that's an empty constructor, right? In my case here. So that was insert after, right? So in the very beginning, even if I had some statements in here, that code block that I just injected would be at the very last line. Like if you wrote it yourself. No magic there. Good? Any more questions? No? Yep.
But how it in refaction? No. Yes.
So which code block you're talking about?
Make and then like string inject code, and I am interested what if we do refaction.
Reflection, you mean?
No, refactoring.
Refactoring, you will break it. It's very brittle. Like the problems we have with our integrations is that, for instance, we are patching some kind of internal of a class inside a framework, and the author of the class in some minor version has spotted that he made a typo. Like he probably would type, let's say the method was called configure, but he made a typo, like he named it like this. And in the next minor version, he makes this fix. Of course, it breaks for us, because we have to account with this name change. And actually, it creates another problem, how to maintain this kind of code. It comes down to the fact of having a good set of test cases for capturing this.
Okay.
Yep, more. Can I use regular expressions, or do I use regular expressions? I'm trying to understand in which context, like. Oh, sure. You can, because it's the same Java code when you are like looking for the method, right? So you can get. No, like, sorry. For instance, like you're looking for a method here, you cannot do that. Like, it's just, it has to be a full name. It has to have like a properly specified signature parameters. So you have to like be explicit on what you're looking for. What you can do is to get all the methods, ask for a name which is a string, and then match on that.
I had a question also. So you should be like very careful with naming of stuff because it might get into conflict with either local variables or method names and so on.
Yes, that's for that we like our method that we add into frameworks. We have like a very special prefix, like underscore underscore gerable underscore random number, whatever. So it doesn't clash like for sure with anything. All right, let's proceed actually. Now I don't remember what I had. Yeah, so why would you use like Javassist at your real work? Like normally, let's say you have a library, and this library or a framework does something that you wanted to do differently. Would you use Javassist for that? No. You should fork the library, provide the patch, write unit tests, and so on. So Javassist is not for that, although you can. You can implement your own framework, but do you really need that? Probably not. So Javassist is mostly used, if you go out and look for the uses of Javassist, it actually is used mostly in tools. Most of the frameworks are not using Javassist anymore. They have migrated off. So Tapestry was using Javassist. It's not using it anymore. OpenWebBeans was using Javassist. It's not using it anymore. Only Hibernate is like the biggest example I know about. Sorry? For performance reasons, mostly. ASM is very fast on instrumentation, and Javassist, it's a bit brittle. So, but it's much more maintainable. Like in our case, for instance, we are patching the frameworks, we are injecting the like big chunks of code into the frameworks, and for us, it's much more maintainable. So if you want to implement your own profiler, that's a good use case, but probably for performance reasons, again, you will look for ASM, not Javassist. Post-processing classes, just some small utilities and so on. But the very interesting use case when you have a third-party solution, let's say you're a company, you have bought in some kind of solution, some application that doesn't provide an API for extension. Mostly, like they do, but sometimes it's just not enough, and you need quickly to react to some changes, implement something. The third-party company says, okay, we provide an extension, but it takes too long. But you need this solution right now. In our case, let me just demonstrate it for you. The NetBeans platform. Who uses NetBeans? Anyone? There is just always at least one. So I counted 4. IntelliJ? Yeah! All right. You are not a Java developer, right? Get out. So, who have used NetBeans? You're like very familiar with it. Who haven't used NetBeans? Well, okay, let's cope with that. There is like the toolbar up there of the launch button and so on, and there is also the configuration for all kind of aspects of NetBeans. And for instance, one little thing is this Java configuration. There is apply code changes after save. So if you're running in a debugger, you are changing the class, recompiling it, you may use this feature to inject the bytecode on the fly without restarting the application, if you only made the change to some statements in the method. But this checkbox is, well, at least until now, I haven't checked the last version, normally it is disabled by default, it's unclicked. And for our solution, it would be very smooth experience, and we don't know about any risks actually that would break if you enable this feature, because it's actually in most cases it's needed rather than not. And we want it to be automatic, but NetBeans API, NetBeans platform itself, although it's very extensible, it has like the capabilities for plugins, extension points, and so on. It doesn't provide a hook for you automatically from the code, from your plugin, to enable that checkbox. So what would you do? Our users want to install from the plugins repository. So for instance, you go to tools, plugins, you get the available plugin, you find Jitterbug there, you download it, once it installs, the IDE says, okay, I want to restart. And then it restarts, the plugin is enabled, but there are some features of the IDE that are disabled and we want them to be enabled. We don't want the user to go to the configuration manual, look for everything, and or like provide a step-by-step guide how to configure your NetBeans to be usable. And instead, what we do, we start the thread that probably the code is not visible anyway. So what we do, we start a thread inside our plugin when the NetBeans is starting. The thread will check if some 13 class is loaded. And if that class is loaded, in our case, we were looking for the implementation of this checkbox here. Once it's loaded, we we intercept that and we enable it. So we are actually patching the IDE itself from plugin to improve the usability. And it's the same for instance, for the servers. So NetBeans did not provide any like facilities to inject your own JVM arguments on the fly. So we wanted like you to just click the button, everything would work, so that you wouldn't have to go like several configuration screens, configure like manually. It should be just, enable the checkbox, boom, everything works. For that as well, we had to patch all the starters for the application servers in like older versions of NetBeans. And once I was talking to NetBeans guys and showing them this ugly code, they were like big guys and they decided to implement this API. So we could remove these hacks, but still those hacks are not removed completely. And for instance, for Maven projects, for this apply code changes checkbox and so on, we have some kind of logic that patches NetBeans platform itself from the plugin. And then, you can use Jitterbug smoothly within NetBeans just because of that. Otherwise, it would be just too many things to configure. All right, that was it. So don't try it at home. Use it with caution. If you have any questions, more questions, try to ask right now, or I have all the slides on speaker deck and also on the SlideShare. You will find them there. If you need a link to GitHub projects, you'll find it from there. Questions? That's the third question.
You mentioned that we should use Javassist with care.
Yep.
So, for example, if I want to implement some kind of logic about logging or something like that, actually I have tried and used Spring's this AUP framework that intercepts some methods, public methods. So, do you have any speed comparisons in case you use AUP with, I don't know which library it uses for bytecode generation, comparing to Javassist if I would generate this custom logging?
So Spring AOP would be generating a proxy. It would not instrument your original class, right? So there you have an overhead of invoking the proxy itself. Probably some more overhead on loading the class definition. I don't have the numbers. I personally don't care about milliseconds. But yeah, you will have some overhead from proxy-based approach. The speed comparison between, let's say, Javassist and ASM comes from the fact that ASM is a bit more level, low level, for instance, so it will be instrumenting your code faster, probably generating more valid bytecode. You have more control over that. And then, well, Javassist is kind of a trade-off between performance and maintainability, I would say. Even though you have tons of code in strings, you can look at it and understand what it does, as opposed to, you know, reading even more code and trying to make up the picture of the code does. That's pretty much it. Yep. More questions? No. We have 4 more minutes, I know. Okay. Chocolate for a question. No?
What are you doing tonight?
Drinking beer with you. Yep.
Have there been any public libraries which would use Javassist to inject a backdoor?
You mean some kind of wrappers around Javassist that would make it easier to work with? Or?
No, to inject the backdoor in application. For example, I download the public library, which actually I use for functionality, but it actually starts backdoor in the background.
Oh yeah, very simple. Yes, you can create that. The question will be, how did you get that library? Normally you would use some kind of dependency management, right? Let's say you are using Maven Central. Yes, it's possible to actually, you know, hijack that protocol and inject a dependency that will go from some other repository than from Maven Central. And if that library gets to your build, which is patched, here you have the backdoor. So it's actually not a question about Javassist itself. It's rather about, you know, dependency management. Good. All right. Thank you very much for coming. I hope you didn't get asleep. And if you have more questions, you know, I'm here still to the end of the day. And bye-bye.